Good day, grade 9s. I hope you are all still doing well and all staying safe during this time, and that you are trying to keep up with your schoolwork so that you aren't too far behind when we get back to school. But we did notice that some of you are struggling quite a bit with the chemistry, which is completely understandable as this is some of the more difficult work we do in natural science in grade 9. So I thought I'd make a few videos just to explain the underlying concepts, and hopefully if you work through the videos and you do all of the activities, you will see that it's actually not that complicated. So let's jump in by looking at the periodic table, and then we will look at the other concepts in future videos. So in this first video, we are just going to go over some of the grade 8 work that you need to know going forward, and make sure you know the terminology and the differences between atoms, molecules, protons, etc. We're also going to recap the structure of the atom, and then we are going to look at the periodic table and make sure you understand how to get all the important information from the periodic table. So first up, some grade 8 revision. You would remember that in grade 8 we defined atoms as the tiny particles that makes up all matter, or we can just say the building blocks of matter. Each atom, however, is made up of smaller subatomic particles called protons, neutrons, and electrons. The protons carry a positive charge and are found in the nucleus of the atom, while the electrons carry a negative charge and are found orbiting around the nucleus. And the neutrons are also found in the nucleus, and they have no charge or are neutral. So over here you can see an animation of an atom. And you can see here in the middle, the red circle is the protons and the neutrons, which is found in the nucleus. And then orbiting around the nucleus, you see here the electrons. Now this pathway that the electrons follow is called an orbital. Okay? Or otherwise, it is an energy level where electrons are found. And these orbitals are going to become quite important a bit later on. So it's important that you understand what we mean when we say orbital. Over here we see a diagram of a lithium atom. Now you should be quite familiar with the structure of an atom by now, but things actually look a bit different in grade 9 than it did in grade 8, so we're quickly going to go through it again. So you start off by writing the heading as with any other diagram, and then you draw the particles inside of the nucleus. And that would be the protons and the neutrons. Now in this case over here the picture is in 3D, so you can't see all of the particles, but you should draw it in 2D so that you can see all of the protons and neutrons separately. Okay, and you should draw 3 protons and 4 neutrons. Then you draw the orbitals, which are the rings or circles around the nucleus where the electrons are found, and you draw the electrons in the orbitals. Now this is where things get a bit more complicated compared to grade 8, because there are more than one orbital and there are 3 electrons, so where do you draw the electrons? Well, it's actually quite simple. We fill the electrons from the inside outwards, and each orbital can take a certain amount of electrons. The first orbital can take 2 electrons, and the second and third orbital can each take 8 electrons. And after that it gets a bit more complicated, but for grade 9 we only have to know the first 3 orbitals. So all you have to remember is 2, 8, 8. And you fill the electrons from the inside outwards, and it's as simple as that. So in this case over here we have 3 electrons, so we place our first one and we place our second one, and then our first orbital is filled up, and then we place our third one in the second orbital, and then we're done. And then technically we still have 7 spaces open for electrons to go in the second orbital, but more on that later. And that's it for the diagram of the atom. Remember all of this because you're going to have to draw a similar atom to this a bit later on. Okay, and then just quickly some more terminology that you have to know. An element is a pure substance with only one kind of atom, and it cannot be broken down. So for example, oxygen, hydrogen, carbon, these are all elements. Compounds, however, are combinations of elements that are bound together with chemical bonds. For example, water, carbon dioxide, and salt. And this is what a lot of the grade 9 work is about. It's about these chemical bonds and how they are formed and how they keep the atoms bound together. So that's what we're going to explore a bit later on in chemistry. Okay, so let's take a look at the periodic table of elements. We are not going to go through the whole table and we're not going to go through every single element. Rather, we are going to analyze it, and I'm going to show you how you can use information from the periodic table to answer almost any question you are going to get in a test or an exam about chemistry in natural science. And yes, you will be given a periodic table in the test or exam, so basically we are providing you with a cheat sheet as long as you know how to read it. The first thing you need to understand is the rows and the columns, or as we like to call them, the periods and the groups. The periods are the rows going from left to right on the periodic table. And there are 7 periods numbered over here, and they are very important because they tell you the number of orbitals an atom has. Now, this information is not that important in grade 9, but it does come up a bit, so you need to understand that the number of periods is equal to the number of orbitals. So for example, if we have a look here at hydrogen, we'll see that it is in period 1, meaning that it only has 1 orbital, compared to magnesium, which is in period 3, it will have 3 orbitals. So, like I said, we're not going to get very deep into this, but it's important that you understand the number of orbitals. Then the groups. The groups are the columns going from the top to the bottom. And there are 8 groups, and you might notice that we skip this whole block here in the middle. Now, we're not going to get much into why this is the case. And it's actually quite complicated, and the numbering system is, you can use different numbering systems, but I'm not going to get into why we use this numbering system, simply because this is the easiest for the work that we have to do in grade 9. But just understand that there is different numbering systems, and this block here in the middle isn't unimportant. It is just easier to explain the work if we use this numbering system. Now, why are the group numbers so important? Well, simply put, the groups gives you the number of electrons in the outer orbital. Now, I know at this point in time it seems very insignificant. Why is the number of electrons in the outer orbital important? But I promise you, this is one of the most important things that you need to understand early on to understand chemistry. Okay, so you need to know that these group numbers correspond with the number of electrons in the outer orbital. Okay, I'm just quickly going to erase everything. I'll be back now. Okay, so if we look at an example, let's look at lithium, since we already drew lithium. Then we see that lithium is in period 2. So if you remember, we drew the nucleus and then we drew 2 orbitals. And the first orbital had its 2 electrons. And then there was 1 electron remaining, and it was in the second orbital. And if we look at the periodic table, then this matches up. It's in period 2, so it has 2 orbitals, 1 and 2. And it is in group 1, and that means it should only have 1 electron in its outer orbital. And that is correct. It only has 1 electron in its outer orbital. Now again, I know this seems insignificant, but it becomes very important later on. Okay, but for now, let's move on. And we look at the individual elements, and we see what we can find out by the information given to us inside of the blocks. So firstly, we see the name of the element and the symbol of the element. Now you should be quite familiar with this, and you should have studied this in grade 7 and grade 8. and you should know it again in grade 9. But let's move on to the two numbers. Firstly, the smaller number is the atomic number, and it will always be a round or a whole number. So it's easy to identify because the other one has a lot of decimals, and this number will be the smaller number of the two. So it's easy to identify the atomic number. Then the second number we have is the atomic mass. So basically it's just the mass of the atom. And these two numbers can tell us a lot more about the atom. So let's have a look at that on the next slide. Before we move on, just quickly, if you need a periodic table, then on page 242 in your textbooks, you'll find a full page periodic table. So for later on when you have to do the activity, go look on that page. Okay, but let's go on and let's look at these numbers and what it can tell us about the atom. Okay, so if we look at the atomic number, which is this number over here, then that tells us the number of protons the atom has. And then if we look at this larger number over here, called the atomic mass, then that tells us how much or what the mass of the atom is. But the interesting thing about the mass of the atom is protons and neutrons weigh about the same. And electrons, compared to protons and neutrons, weigh almost nothing. So basically we can say that the atomic mass is basically the number of protons plus the number of neutrons. And if we do that, then we can calculate the number of neutrons since we already have the number of protons. But before we do that, we first need to round this number because there isn't 3.941 neutrons. Okay, there's a whole number of neutrons. So you round it either up or down to whatever is the closest whole number. So in this case, that would be 7. So the atomic mass is equal to the number of protons, which is 3, plus the number of neutrons. And if you rearrange it, then you would see that neutrons is equal to 7 minus 3, which is equal to 4. And then for electrons, it's also quite simple. Electrons are equal to protons if the atom is neutral. Now we'll talk a bit later about what does it mean when the atom is neutral, or what's the difference. But for now, you can say that electrons equals protons. So let's just quickly look at how this all plays out for this atom lithium. Okay, protons is equal to the atomic number, which means protons is equal to 3. Then neutrons is equal to the atomic mass minus the atomic number, or you can say minus protons. And that is 7 minus 3, that's equal to 4. And electrons is equal to protons when neutral, so that means electrons is equal to 3. Okay, fairly simple, but this is what you're going to have to do for the first activity, so just remember it. Okay, and here we get to activity number 1. You basically have to complete this table using the information that you just learned. So just to help you, I'm going to do the first one for you so that you can see what steps you are supposed to take in this process. Okay, so firstly we see here the symbol Ca, and if you go look up in your periodic table, if you remember from grade 8, Ca is for calcium. Then we look for the number of protons, and the protons is the atomic number. The atomic number is the smaller number, and that's 20. So protons is equal to 20. Then neutrons is equal to the atomic mass minus the protons, or minus the atomic number. So that is 40 minus 20, and that is equal to 20. Then the atomic mass we already used over here, so we can just carry it over. The atomic mass is 40, and the electrons is equal to the protons, so that is also 20. Okay, simple as that. Do it for the rest of the table, and that's the first part of the activity. Then, for the second part of the activity, you have to draw a beryllium atom. Okay, so this over here is a lithium atom, so that's not what you're supposed to draw. This is just an example, but it's very similar. Okay, so just go look on your periodic table and you'll see beryllium. Okay, and you just change this drawing for lithium to one for beryllium. Okay, also please draw this block for beryllium. Okay, so just include this information, or the information for beryllium instead of for lithium, just so that you can see where some of this comes from. So based on the information on this block, you should be able to help, it should be able to help you draw this atom. Okay, and that's it for the first video. Like I said in the beginning, if you follow these videos and you do the activities, it will all be a lot easier for you. Okay, so in your own time, please work through the videos and work through the activities, and you'll see that chemistry is actually not that complicated. Okay, good luck.